So what I have is two DSSs here for you showing when we do the power failover, we're going to actually physically pull the power plug from what we have here is DSSD6. By the way, I'm using the latest version, 6156. If you're not up to date, I please advise it because it's a stable version that we work on. But here, I'm going to go to Setup Network Failover, and this is presumably that everybody understands how to set up the auto failover service. And what we'll do is while the primary is rebooting, I'll take you to some areas for screenshots and how-tos to set up your auto failover, so it's very easy. So the primary system I'm working on right now, if you look at the address of the browser where I have the IP address, I have one that's set for 1.220, and the destination is 221. And again, we'll just go to Setup, Network, and then Failover. And here you'll see that this is the secondary passive server. Now, we're working with the virtual IP address that our targets are connecting to, which you'll see is 1.13. And both of them are set to this on E3 that I have. And also in the how-to resources and the guides and other videos, you want to make sure that these are the same or your auto failover service will not engage. So please be aware of that. And what I've done on this is, if you look here, I have my Microsoft iSCSI initiator set as well for 1.13. Make sure that you're able to see that. Because it looks like it's not coming up. There we go. Transfer desktop. And there you'll see the initiator settings that I have. And of course, I have 3 targets. I'm only going to use one of them right now. And what we've done is, of course, we're put in the iSCSI target here that we've labeled in the Microsoft Disk Manager. And we've called it iSCSI DSSD6, and we're given the drive letter of F. So what I've done is put some files on F that we will demonstrate that they'll be there for when you do the failover. So at this point in time, what we're going to do is we're going to ping the virtual IP address from Microsoft, and we see that it's live. And right now we're going to, let's do a continuous ping. We'll put a -T at the end. And you see that the virtual IP address is alive on the primary. And when we drop, we'll see that all of a sudden you see a virtual timeout. Now, let's go to the primary and see if we can get to the GUI. And it looks like there is a momentarily, it's been dropped. And let's verify that. Let's open up another window here and let's ping the primary management IP address that I have, 192.168.1.220. Okay, so now it's offline. We're not able to access the GUI. It's timing out that IP address. And here we can even log in back in. So it is virtually dead at this point in time. So I'm not able to get a ping from it. We've already simulated the power failover. The virtual IP address that you're seeing is still coming up from the secondary. And as you see now, the primary is not reachable. So if we go to the DSS on the destination side, we are receiving an alert message. And typically what you're going to see here is the first part is going to be failover secondary node, the ETH link. Now that link I have set for the auxiliary port, and that's my volume replication. Nick, that's dedicated for the volume replication. You should have the auxiliary port connected to it. ETH3 is my virtual IP address, and that too has my auxiliary port connection as well. ETH1 is the primary IP address that is not communicating to the primary server. The secondary is recognizing it. It's communicating to the heartbeat. I cannot access the primary, and it took over. So this is all working with the ping node, the auxiliary ports, and our failover service mechanisms that once the communication has been broken or is not established, then what's going to happen is you're going to get this message. So what you're seeing here is the volume replication device on, let's see if I can make this a little bit bigger. There we go. If the volume reference on LV001, 02, here you'll see that connection went from connected to standalone, okay, and then it went to primary to unknown. I'm going to show you this and give you some examples of what this, not only the definition means, and also for you to understand that if you do have some type of issue where you have a slip lane or you don't know who is primary, we can go through some of the steps to let you know who is actually the active server. So if we come right into, let's scroll down, there we go, I'll take that screen off. We go to the secondary, we go to the failover. You can see that he has promoted himself as the active server. And it's noted as a graded state. So what that means, it's almost like a RAID 1. And so now he's on by himself. We're still able to ping the virtual IP address. Oops, that's the wrong screen. And here's our 1.13 virtual IP address, and we're still able to communicate with the secondary active server. Now, what about our data? Well, as we see, our data still here, our F drive, and let's put some new data on there. So that way you can see that while you're putting data on there, that the data is transferred over once the primary comes back online, and we can synchronize the volumes and then do the failover back. So here we'll just copy some small files because I want to let you know that if you have large files into the gigs or many gigabytes that you've made some changes over, because sometimes the primary won't be online because you may have to either do a RAID rebuild or something might have happened to the RAID array, or there might have been a physical damage to the machine, and that might take time for you to repair. So while the more data is being added to these volumes, that will have to be synchronized over to the primary, and we'll demonstrate that. Obviously, I can't put large amounts of data because we would be sitting here for more than 5 minutes, watching data being synchronized over to the primary, and I know we have more time to do that. But just to let you know, when we do, that can take time. Okay, so now we've added additional files and data into the F drive. Let's go ahead and bring that down. Now, what I want to let you know, what we'll do is we'll clear out, and you'll see that E0, E3, and E5. Again, this is my management and also my storage port. This is my virtual IP address that I'm using, and this is my volume replication NIC. Keep in mind that you always want to use the volume replication network interface card solely for the volume replication. Sometimes we've seen customers use the volume replication NIC for virtually a lot of things, and that kind of will give you a performance issue. So you really want to dedicate typically 10 gig E for a large volumes or high IOs where you're getting a lot of data. Use a 10 gig E and you can directly connect them without having a switch involved, which can save you money. So bear that in mind. Now, when we go down, let's go all the way down to the bottom here. You'll see that there are 3 tasks and that it states that it's now active. So we'll just go ahead and clear this check mark out. And right now I cannot sync volumes yet, but looks like we're back up. So let's verify. And let's ping our primary server. We'll go 1.220, and it looks like we're back up. And let's go to the GUI. And here we are. So let's let that log on. There we go. And we have our messages from the primary. And here it states that the system was not shut down properly and could lead to file system corruption, and it is recommended to do a repair file system. That repair file system is in the console tools, in the console screen where you do Control-Alt-X, and you can do a repair file system on the logical volumes. So here you'll see that we're going to clear these out because we're going to show you some fresh messages. And also the destination, we'll clear those out so you have a better understanding. But I wanted to point this out to you is that if you look here, it says primary unknown. A lot of times people will ask, well, what do these messages mean? And so you want to be able to interpret them. So we do have them all listed. If you want to look also, if you look at the task status, here you'll see destination unknown for each of the tasks that I have set. And there might be different messages, by the way. Some that are, if you're doing over WAN replication, you may have a different message. Here in our website, I wanted to let you know that this search engine is very popular. It works very well. It searches our forums, it searches our website, and also our knowledge base. So let's take a look at what DU unknown means. We'll just type that in. And it's going to search our website. And here you can sort the knowledge base. I like to use knowledge base because we keep these updated. The support engineers, we all put these in, especially for cases that we see that might be helpful. So if we look at the description and connection status in relation to replications, here you'll see the description of the connections in relation to replications. And here is where we have the destination unknown and what the state is. So basically it's saying the state is used for pure disk if no network connection is available. And that's what happened. So when the system powered off, there was no network connectivity. Ping node couldn't communicate to the primary, the auxiliaries, all the scripts were trying to do its best to communicate with it. And at that point, it happens instantly on the failover. So I just wanted to point that out, that when you want to search for information, to use the search engine on our website, that it does have a lot of useful information if you ever want to know anything. Okay, so now let's go back to our destination server. One of the things that I wanted to point out is if in the event, you really should be setting up the DSS v6 with the email alerting system. Before we do a failback and synchronize the volumes, I want to show you that you probably want to set up your email alert system. So it's not just good just to have the event viewer, but you should also have another way to be able to be alerted if there was a power failure. If we go to Setup Administrator, and we'll scroll on down, you want to be able to use what's called the email notification for errors. So here, what you want to set is, here I just put the OpenE contact count that we have. You can have multiples, and so we're going to put the password in. And what we have is some other advanced features for ports. We're going to use the default port 25 for our outgoing email. And you can have destination emails as well and set those. And once you hit apply, it's going to send out a test message. So it's asking you, please check your emails. So right now, let's go ahead and check our email and see if they've come in. So I've set up an account here. And here's our test from DSS on our destination that we did. So this was just seconds ago that we just went ahead and applied this account inside DSS v6. So when you set up, before you do your auto failover service, actually you should do it just when you install DSS v6. Always set up an email account for email notification. At least you can get some type of messaging alerting system that will let you know what's happening to your DSS v6. Also, there's a remote log server that's kind of interesting too. They can send you logs. So you use a Linux machine. If you click on this question mark, will give you detailed information how to set that up. To set up the syslog.ng.conf file on the server side. So what will happen is that DSS will send you the log files in advance of changes in DSS, or there's been some type of updates on the log, and that way you can receive logs. So this is very useful, and it works, and I think that you should really make this your standing operating procedure with DSS v6 to set up your email before you really start putting any tasks, any type of replications, or even your targets or your NAS shares, any type of volume structure. And it's very important to have. All right, now let's go back to the setup and into our network failover. And let's proceed with the failback. So what we want to do is we added new files, going back to this again, that we added these two new files. Okay? We want to see if they come back alive and are replicated back over to the primary and put everything back to its original position, as if the primary has been repaired, fixed, and let's go ahead and proceed with that. What you want to do is you want to scroll all the way down to the bottom, and here the only 3 buttons that are available are stop, sync volumes, and fail back. You want to be able to sync the volumes first. Obviously, we don't want to stop the service, so we want to sync. And what this is doing is communicating back to the primary, and it's checking the volumes, it's updating the delta difference between the two, and it's replicating the data over to the primary. Data can still be written to that virtual IP address, and it will keep replicating until it passes it over. So here we have new alerts. If we look at the alert tab here, it's stating that it's now going from consistent to consistent, and this is what we want to see. So let's take a look up on top. Where you want to go is right here into the task status. If you see this and all your volumes in a consistent state that is showing right now, instead of destination unknown, or that it's still updating, it'll give you a percent value as well. So it might say you've got 2 minutes left to replicate 500 more meg of the data from the secondary to the primary. So you want to wait till those all become consistent before you can begin the next step. So the next step, once if all the tasks are consistent, then you can go ahead and proceed with the failback. There is a question that says, this is using DRBD. Yes, it is using DRBD. All right, so let's go ahead and use the failback. So failback's in process. And once this is checking, what it's doing is verifying all the auxiliary ports, the ping node, verifying the data that it's actually matching up with the secondary that the primary has now been updated with. And once that's completed, then it'll state your node is now passive. And let's verify that. And of course, we get the update from the info from our event viewer. And here we see that our NICs are connected okay, that the ping node status is okay, and it has updated itself to secondary passive, and the service is running fine. And now let's take a look at the source. We'll go to Setup, Network, Failover. And we see now that the server's back online from a power hit, and we just basically pulled the cable, the power cable from the subprimary, brought it back online. We synced the data back from the task, from the volumes, and we did a failback. And now we're back to our original position right here from the primary active, and let's take a look at the data. And our data is still there. So there is something that if you do have a power failure on the primary, don't worry, your data is fine. You can continue writing data even when the power is off, because everything is transferred over to the secondary and it becomes active immediately at that point. You will not lose your data at that point. I do want to make a point that if you are setting up the auto failover service and you're using the iSCSI volumes, you want to make sure that on the iSCSI target manager in your targets for the ones, you want to make sure that you do not set the write back functionality on for your iSCSI logical volumes. This is because we're not replicating the cache on this. Now, this feature will be added in possibly this year, so be aware that we will be adding that functionality. Additionally, if you look at your status on your volumes for your replication, you can go to Status, Task, and here you will also see, especially for new volumes that you create and you want to add to the task from your volume replication, here you can see the status once they're connected. And if they're consistent amongst the primary and secondary source and destination. So again, you want to be able to make sure that your email status is up, and also if you wanted to investigate who is primary and who is secondary, or what events that took place, go to status hardware. And this is how us as engineers, when we support you in cases, and if you're not familiar on reading logs, I just want to point this out, that when we read logs, we pretty much go right here into Log Viewer, or we download the logs and view them. And what we'll do is we'll go right and scroll on down, and we'll look at the HA debug or the HA log. If we open this up, and we'll just use WordPad, you can see the events that take place here. Let's see if I can blow this up here. So you can look at the events that took place. Here you'll see that the link info is up, and it goes up, and remote resource transition is completed. It looks like it failed. That's when we pulled the power table. And here we're running the acquiring resources, and here's your information, DRBD disk. That was from one of the questions that you asked. And then once we did the failover, standby resources acquisition is done, and remote resources is completed. So a lot of this information, there's more also in another, what's called the HA logs, the debug logs, and you can read these as well. So there's some information that kind of helps you if you are in a position where both power fail, but they're right next to each other and you do not know who is actually source. Because what will happen is in your volume replication, if you look here, right now, this is locked down as source. You cannot change these. You cannot modify them until you stop the task. What would happen in some cases in the older versions, which has all been corrected now in the latest one, especially the last 3 versions that we created, if both of them were to show source, okay, if this actually was source, source, source on the secondary, and on the primary, over here we see source, 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 how do you know which one is the real last source or the real last data that was written? Because if you selected the wrong one, you could be actually having the older data. Very simple. You look at the HA logs, compare the two, who took over, and that it tells you who is actually source. And at that point in time, you set that one back to destination and apply your task. Well, everyone, I hope that helps with understanding and trusting when a power failure hits. Oh, by the way, I want to let you know, if the secondary has a power hit, actually all you do is bring it back online and they resync back up. So really, that's not a real big issue there. Yes, somebody's asking about split brain. That's kind of what I was explaining before, is if that is a split brain, if you both are in source, immediate, especially with the older versions, what you do is you look at that HA log and basically tell the difference between who actually took over at that moment in time. And if you have issues in looking at the log, send in a support ticket simulating that, or we could actually do another webinar doing split brains. But those are pretty much have been eliminated with our auto failover mechanisms that we added in the last 2 releases, especially with the IO error detection that we instituted, and that's in the release notes. And the IO error detection that pretty much does the same, that it prevents the split brain. It also prevents from array controller issues that causes a lot of that problem as well. I want to bring everybody to the last point that, you know, a lot of this information that we have is under the support and right here in our knowledge base articles as well as the libraries. What I want you to refer to is a lot of the how-to resources. So here you can look at our iStudy, how to set up the synchronous volume replication with failover, broadcast, unicast, and also for NFS. If you're using block devices, please use MPIO. We're seeing still a lot of people using bonding with block devices. Really, MPIO provides you the best performance and a path failover. Keep that in mind, especially when we are seeing a lot of customers using 802.3 AD, which is fine for iStudy, but most we're seeing better performance with MPIO with the round robin, especially with VMware. Although this is ESXi 4.x, it works similar with 5.1. Additionally, before I close out, the webcasts and videos. There is a plethora of information here, especially with LSI array controllers. That I personally had LSI here, and they provide a lot of information on the LSI array controller. Additionally, Giannis has done some with the Adaptive Max Cache. So a lot of you who are using the Adaptive array controllers will find a wealth of information there, as well as the SSDs. Here there's a lot of new things like adding new tasks with Auto Failover. So that's a really interesting one. It's finally in our releases, so you guys can enjoy that. Well, everyone, take care. Thank you very much for coming. I hope that was short enough. I know a lot of you are busy, but at least you'll have comfort in knowing that when you have a power failure, that you can recover very easily and your data will be preserved.